Hi friends, in every lesson, there's an opportunity to change the world for the better. Given some salt compound, we're asked to determine which compound has the highest lattice enthalpy. Let's move on to the wetting sheet. Salt molecules are arranged in a repetitive and orderly manner, forming crystals. Crystal structures can be depicted as lattice, where each lattice is occupied by an atom. The relationship between the points of the crystal lattice in a geometric shape is called a crystal lattice. Besides depicting the distances between atoms, the lines in the crystal lattice also depict the bonds between atoms, more precisely, ionic bonds. When these bonds are broken, ions are released from the salt crystal. From here we learn about lattice enthalpy. Lattice enthalpy is the energy required to separate 1 mole of a solid ionic compound into its ions in the gas phase. The value for 1 mole of salt is the same for all salts. What differs is the binding energy between atoms. The greater the binding energy between atoms, the greater the lattice enthalpy. Therefore, we will calculate the binding energy of each compound as the value of the binding force, because the binding energy is proportional to the value of the binding force. Let's say there is a positive ion and a negative ion. Positively charged particles will be attracted to negatively charged particles, and vice versa. The two ions will stick to each other. This is the process of ionic bond formation. The magnitude of the binding force between ions can be calculated using Coulomb's law. F is equal to Kq1Q2 divided by R squared, where Q1 is the charge of particle 1, Q2 is the charge of particle 2, and R is the distance between the atomic nuclei. We will apply this formula to the compounds listed on the problem sheet. There are magnesium oxide, magnesium sulfide, sodium fluoride, sodium chloride, and sodium bromide. We need to know the charge of each ion, so we will write this compound in terms of its ions. Magnesium oxide is formed from magnesium ions with a charge of 2+ and oxygen ions with a charge of 2-. This means the charge of the magnesium ion is plus to Q, and the charge of the oxygen ion is minus to Q. Likewise for the others. Now we will analyze the distance between ions. We can represent the size of the ion as the size of the atom. The size of the atom is based on the atomic shell. If we have ever watched the Bohr atomic theory, the distance of the atomic shell to the atomic nucleus can be written as a 0n², where AO is the Bohr radius and n is the atomic shell number. The magnesium atom is in period 3. Its atomic radius is about 9a0 because n is 3. Oxygen is in period 2. Its atomic radius is about 4a0 because the two ions are attached to each other. The distance between the atomic nuclei is the sum of each radius. R is equal to 13a0. The magnitude of the ionic bond can be calculated through the Coulomb force. A little calculation, 0.02367 K times the square of Q per AO. We can ignore the minus sign because it only indicates the binding force. In the same way, the binding force of magnesium sulfide is 0.0135 K times the square of Q per AO. Sodium fluoride 0.0059 to K times the square of Q per AO. sodium chloride 0.00308 K times the square of Q per AO, and sodium bromide 0.0016 K times the square of Q per AO. It is clearly seen that the binding force between ions in magnesium oxide is the largest. This means that more energy is needed to break the binding force. If we are connected to the internet, we can see the magnitude of the lattice energy for each salt compound. It turns out that the magnitude of the binding force is proportional to the lattice enthalpy. So the correct answer is A. Happy learning, everyone.